In this video, we will see dry run of the code. So now let's see a quick dry run of this code. So here we have an array, we have an answer array, we have this stack, and we have n equals to 8. Okay. This stack you can understand it's like in your array simple. Okay. So we will understand both these things. Okay. So let's suppose this is also your stack. And yeah, let's see. Let's see that. So I will simply add the indexes 0, 1, 2, 3, 4, 5, 6, 7. Let's start. So we have an stack. Yes, this is my empty stack. We have n equals to array dot length, that is 8. We have an answer array. Yes. Then I will start from 0. So I will start from here. Okay. And I will check is my stack dot length is not equals to 0. No, it's equal to 0. So I won't come inside this while loop. I will directly come here. I will check is my stack dot length is equals to 0. Yes, it is. So answer dot push -1. So I will push -1. In the last, I will push array I, the current element, I will add 1. So I will add 1 here, I will add 1 here. Okay. And I pointer will move. I pointer will be here now. Okay. I pointer is here. I will check again while stack dot length is not equals to 0. Yes, stack length is not equals to 0. And the stack topmost element is stack dot length -1. What is the stack dot length -1? Don't think that this is a fixed size. Okay. Consider it as a dynamic, or if it is creating a confusion, we can create a simple array, something like this, right? So what is stack dot length -1? This is 1. Okay. Is it greater than equals to array I? No, it is not greater. Okay, it is lesser than. So I will come here, I will check is my stack length is 0? No, it is not. But I will come to else part and I will push stack top element because that 1 is smaller. So I will push 1. Again, my I pointer will move. Okay. And before moving, I will push into array I. So I will push 6 array I and I will push 6 here as well. Okay. Now my I pointer is pointing to here. Is your stack length is equal to 0? No, it is not. Okay. It's not equals to 0. Yes. And stack dot length, the last element, like stack dot length -1, the topmost element, 6. Is it greater than equals to array I? Yes, it is. So simply pop it out. So I will pop it out, remove it from here. So now once I pop it out, again I will check is it not equals to 0? Yes, it is not equals to 0. Okay, I distorted my stack sheet. So this should be something like this. Yeah. So now what I will do, I will check is your stack dot topmost element, that is 1, is greater than equals to array I? No, it is not greater, it is less than. Okay. So I will come here in the else condition because stack length is not 0. I will come in the else condition and I will push the topmost element, that is 1. So I will push 1 here. So for 6, you can see for 6, 1 is the answer. For 4 as well, 1 is the answer. Okay. Now I will check for a 10 and before moving, I will simply push 4 here. I will push 4 here. Okay. Now for a 10, again, is this stack dot length is not equals to 0? Yes, it is not equals to 0. Is this stack dot length -1? That means the last element, the last 4. Is it greater than equals to array I? Greater than 10? No, it is not. Okay. So I won't come inside the while loop. I will come here. I'll check is my length is equals to 0? No, length is also not equals to 0. I will simply push the element here. That means 4 is the smaller element. Yes, so I will push in my answer array. And after this, I will push 10 in the stack. So I will push 10 here and I will push 10 here as well. Okay. Once I have done it, I will simply move with the I pointer. Okay. I will check that I have 2 and I will check is my stack length is not equals to 0. Yes, it is not equals to 0. Your top element of a stack, that is 10, is it greater than equals to array I? Yes, it is. So pop it out. So I will simply pop out. Simply pop out. Now, next element. Is the stack length is not equals to 0? Yes, it is. Is your topmost element is greater than equals to array I? Yes, it is. Greater. So pop out. Pop out. Okay. Now, again, is stack length is not equals to 0? Yes, it is. Is your topmost element is greater than equals to? No, it's not greater. So I will come under here. If condition won't true because stack length is not equals to 0. Okay, else I will push stack top element here. I'm sorry. And before moving, I will simply put 2 here. I will simply put 2 here. Now for 5, I will check, is your length is not equals to 0? Yes, it is. Is your topmost element is greater? No, it's not. So I will simply come here. I will check answer dot push. So I will push the topmost element. So I will push 2 here. And before moving ahead, I will push 5 into my stack. Push 5 into my stack. Okay. I will check. This is done. I will check for 3. Is your stack is not equals to 0? Yes, it is. Is your stack topmost element is greater than the current element? Yes, it is. So pop it out. Pop it out. I will pop out. Now again, is your stack length is not equals to 0? Yes, it is not equals to 0. And your element is stack topmost element is greater? No, it's not. So I will come else condition and I will mention 2 here. Okay. And once I mention, I will simply push 3 into my stack. Now for 1, is your stack dot length is not equals to 0? Yes, it is not. Is your stack topmost element is greater than the current element? Yes, it is. Pop out. So I will pop out. Again, is your stack length is not equals to 0? Yes, it is. Is your stack topmost element is greater than the current element? Yes, it is. Pop out. Pop out. Is your stack length is not equals to 0? Yes, it is. Is it greater than topmost element is greater than or equal to your current element? Yes, it is equal. So pop out. Pop out. Okay. Now I will come here. Is your stack length is 0? Yes, it is. Okay. It is. So simply push -1. I will push -1. Will be my answer. In the last we can like push 1. There won't be any use. I will get this as an answer. Again you can see, okay, my while loop is also running, okay, but the while loop is only running not in each time, in each iteration it is not running, okay, in each iteration it is not running. For a specific iteration it can run up to n times, okay. So again the time complexity here will be big O of n, and space complexity will also be big O of n, one for stack, one for answer array. Okay. So now let's see few important points before ending this session. We have this code. Okay. What we have covered nearest smaller element on left. Okay. On left. Can you apply the next thing, that your nearest smaller element on right? Simply smaller element on right. So you don't need to do much thing here, right? The same code will be there, right? Just you are starting from 0 to n. Maybe you need to start from the right direction, right? To start from, suppose if I copy this, so this is my array, right? I'm saying nearest smaller element on the right side. So here we were checking on the left side, right? We were checking on the left side. We were taking array one by one. We are moving in this direction. Okay. Now you are checking on the right side. So you can check from here, right? You need to traverse from here and you need to check, is there element on the right side? Is there element on the right side? Is there element on the right side? Okay. So there will be few tweaks here and there. You just need to start loop from n minus 1 to 0, okay, and then you can solve it. So that's a second problem, okay. I want you to try, because this is how you will get it, okay. So one more thing, right? So there will be total 4 types. One, nearest smaller element on the right side. Next thing can be nearest greater element, okay. So like this we have find out a smaller element on the left, there can be nearest greater element on the left. Okay. The fourth part can be nearest greater element on the right. So check out how you can apply all these things, right? You should be able to achieve all the 4 algorithms, right? Nearest smaller element on the left, nearest. So then you will be very good in stack data structure, right? You can find out more problems. Okay. All the problems are there in different platforms like Geeks of Geeks, Lead Code, and go ahead. You can try, check it out. there won't be too much edits in the code. Okay, you just to start like for greater element, instead of finding like stack dot length, if it is greater, then you are popping out, right? So what you need to do when there is a greater element, okay, if the topmost element is smaller, then you will pop it out. Okay, so yes, there will be few tweaks here and here. That's it. Okay, and then you will able to solve all these four types of question. And trust me, these four types are important. Okay, I have covered the fundamental. Okay, but from now onwards, we will try to solve more and more complex problems. That's all for today. See you in the next